Okay, so I printed off all of the problems for the practice final for Math 20, beginning algebra. And what I'm going to do is I'm going to walk us through how we would work all of these out. Please note that if you are looking at my scanned in document where I work through all the problems will be the same, but the numbers will be slightly different because I printed off this packet of problems after I'd already worked through it once before. So it's the same style of problems, just different numbers, and when you open up your own practice final, you will have the same problems with different numbers, so the processes are the same. Just know that going into it. And also I want to point out that when you are doing any of these tests, mine, because it's printed, will have the ID down here at the bottom, but yours, if you're in Pearson, will have them up there at the top. And remember, the first number tells you what chapter the problem originates from, and the second number tells you what section it originates from. You don't need to worry about the last number because that's just the number of the problem from that section, and it really doesn't matter. What does matter is that you have the chapter. So this first problem's from chapter 1, section 5. So if you're struggling with a problem, you can go back to that section and go back to that homework assignment, and you could redo it or go back to your notes, however is going to be most helpful for you. Okay, so let's dive in. Number 1 says find the absolute value. Remember, absolute value is the distance a number is from 0, and if you need a visual representation, remember you are always able to make a number line. We'll stick the numbers 0, 1, -1, -2, -3, -4. You can always do a very visual way. If you are a visual learner, that might be the best way. And if we're starting at -4, then how much do we need to go to get to 0? Well, we're going to go 1, 2, 3, 4. So the absolute value of -4 is simply +4. Now, number 2 and number 3 I'm going to kind of address together because they're very similar. And it's very often that we get these two confused, and as I've warned before, some calculators actually do both of these problems exactly the same, and that is incorrect. And so remember that the parentheses are super important. Like on number 3, there's parentheses around the -3, which means everything in that parenthesis will get raised to the second power. Number 2, though, there are no parentheses. So that means that negative right here has nothing to do with that exponent. Remember, we are able to write this as -1 times 6 squared. Because that negative out there just simply tells us we have a -1 attached to this, but since there's no parentheses, that power of 2 only means it goes to the 6. So that'd be -1 times 6, which gives us a grand total of -36. This is very different than what's happening in number 3, where we have the parentheses around the negative. That means that that power of 2 also goes to the negative. Everything in here is getting raised to the power of 2. So we're saying we have -3 times -3. Negative times a negative is a positive. 3 times 3 is 9. So notice if you don't pay close attention to the parentheses, you're going to get this wrong because one of them ended up being negative and one of them ended up being positive. And so we have to really pay attention to what they give us. All right, number 4 is all about order of operations. We have -36 minus 6, and then in the parentheses we have 2 minus 4 raised to the second power. Remember, our order of operations is PEMDAS, so the P tells us we have to do what's inside of the parentheses first. So that means I'm going to do the 2 minus 4 inside the parentheses first, which produces a -2. PEMDAS, the E tells us exponents come next, so I'm going to be taking -2 to the second power, which is literally what we just did up here, guys. Only up here we had -3 to the second power. Right here we're going to have -2 to the second power. So that'd be -2 times -2, which is a +4. Now the two operations left to us is we have -36 minus 6 and then -6 times 4. So what we're going to do is we're going to do multiplication because multiplication comes before subtraction. So we'll have a -6 times a +4 producing a -24. Now we have only one operation left. We have -36 minus 24, and that gives us a grand total of a 60. So PEMDAS. First we did the parenthesis, then we did the exponent, then we did the multiplication, then we did the subtraction. That's what we did on that problem. PEMDAS. Number 5 says simplify the expression by combining like terms. Remember, to be a like term, you have to have the same variable with the same exponent. We have negative 9g plus 2g. These do have the same variable, and they do have the same exponent. Remember, if there's no exponent written on a variable, it's understood that that variable, or excuse me, that exponent is a 1. We just don't write it in. So what we're doing, excuse me, is we take negative 9 plus 2, and that'll give us a negative 7, and then we say negative 7 what's? Well, negative 7 g's. And we make sure and include that. Be careful on Pearson that you don't put spaces, and also that if they give you a lowercase letter, you give them a lowercase letter. If they give you an uppercase letter, you give them an uppercase letter. All right, number 6 is x equal to is x equal to 1/6 a solution to 12x minus 12 equals 6x minus 6. So what we have to do here is we have to plug in the 1/6 into each of our x locations. So we will have 12 and then times x, which is 1/6, minus 12 equals 6x, which is 1/6, minus 6. And then what we're going to do is this would be 12 over 6, or I like to simplify on the front end. And what that means is I know I'm going to have a 12 on top, but I know 12 is 6 times 2. If you have a 6 on top and a 6 on bottom, those will cancel, leaving me with 2 times 1, which is 2. Then we saw the minus 12 and equals. And then over here on the right-hand side, I have a 6 and a 6. I don't even have to do any kind of factoring there. Those are going to cancel, leaving me simply with a 1 minus 6. On the left-hand side, I have 2 minus 12, which is negative 10. On the right-hand side, I have 1 minus 6, which is a negative 5. Does negative 10 equal negative 5? No. This is not a true statement. So no, 1/6 is not a possible solution for this equation. If you would have gotten negative 10 equals negative 10, then the answer would have been yes. All right, let's move up to number 7. Solve the equation and check your solution. I'm not going to be checking my solutions on these, but that is always your best option. What I highly recommend is when you're working through your final, work all your problems, and then if you have time, which you should because you're given a 2-hour window to take your final, then go back and check your work. And the way you check it is the way we just did that last problem, where you plug it back into the original equation and make sure that it works. So if we're solving x minus 7 equals a negative 11, I'm trying to get my variable, the x, by itself. Right now I have this minus 7 attached to it, so in order to get that away, I have to do the opposite. The opposite of subtraction is addition, but if I do it to the left, I have to do it to the right because that's what being an equation means. It means we keep things equal or we keep things balanced by doing the same thing on both sides. When I do that, that leaves me with an x on the left. Negative 11 plus 7 gives me a negative 4. So my answer would be negative 4. I'm going to be doing the exact same thing on number 8 where it says solve the equation. I have a negative 2 equals 3 plus x. Yes, my variable is on the other side. That doesn't change anything because I can move all of my terms from left to right or right to left. So since this is a positive 3, to move it over to the other side, I would subtract it. But if I subtract 3 from the right-hand side, I have to subtract 3 from the left-hand side. Negative 2 minus 3 is a negative 5 equals x. Same exact style of problem on those two. One of them we had to add to move our number over, the other one we had to subtract because we do the opposite. With number 9, we have negative 8 equals a negative 4 over 5z. Now, we can do exactly what we've been doing where we just do the opposites, but personally, I find that if either of these numbers really are a fraction, the easiest way to do this is using the multiplicative inverse method. instead of doing the opposites method. That way I don't have to worry about dividing by a fraction anywhere along the way. And so the multiplicative inverse method is where I look at the number that's in front of my variable, because I'm trying to get my variable by itself. And my number is -4/5. And I need this number to go to 1 so that my z is by itself. So in order to do that, what I do is I flip my fraction and I multiply both sides of my equation by that flip or by that multiplicative inverse. So if I flip this, that would give me a -5/4. But I have to multiply everything by that -5/4, not just this one side, because again, we got to do it to both sides. And if you don't believe me that this is how it works, watch. We have a -4/5 times a -5/4. That gives us a positive 20/20, which gives us a 1. That is the whole reason we do the multiplicative inverse method. Now, if I'm multiplying -8 by -5/4 though, I might need to do that over here on the side. And remember that if I am multiplying a whole number by a fraction, I can make any whole number into a fraction by sticking it over 1. And then again, I generally like to do my simplification before I do my multiplication. And I notice that I will have an 8 on top and a 4 on bottom, and I know that 8 is 4 times 2. Which means I have a 4 on top and a 4 on bottom. So I cancel those out, meaning I'm going to be taking a -2 times a -5, and on the bottom it's just 1. -2 times -5 is a positive 10. So when I multiply -8 by -5/4, I get a positive 10. And on the right-hand side, we saw that my number went to 1, which was the whole point. So I get z equals 10. And again, you can check these by plugging them back in like we did on the previous problems, and we can check to make sure it works. Number 10, guys, works exactly the same way. Exactly the same way. We have 3/8x equals 6. And again, I don't want to worry about dividing by a fraction where I have to keep, change, flip, so I'm going to choose again to do my multiplicative inverse method. That means I'm going to multiply both sides by the flip, which will be 8/3. And I'm going to come over to the side again. I'll do a little bit of side work. I just showed on the first one, though, that if I multiply by the multiplicative inverse, I get 1. So I'm not going to do this side. I'm just going to say this is going to be x. I am going to come over to the side and take 8/3 times 6 so I can figure out what that is. I have 8/3 times 6, but I put that over 1. And again, I'm going to choose to simplify first because I know that 6 is 3 times 2, so that 3's will cancel, leaving me with 8 times 2, which is 16. That means x is 16. Now, do you have to use the multiplicative inverse method? No. If you wanted to keep, change, flip by dividing by a fraction, you absolutely could. There's nothing wrong with that. You would end up with the exact same answer. It all depends on your comfortability with fractions. Personally, I would like to get rid of all the fractions as quickly as possible, which is why I do it this way. All right, number 11, solve the equation. This is out of 2.4. First thing we're going to do is we're going to look for like terms. I'm actually going to rewrite it over here just so that I have a little bit more space to show you my steps. So I'm going to look for like terms, and I have a 6x and a minus 3x. Those are like terms. So I can take 23 equals 6x minus 3x is 3x. Then I need to get my variable by itself. And remember, my kind of lame example is that the 3 is like it's hugging the x, but this 5 is like a handhold, and it's easier to break a handhold first. So I'm going to break that first, and since it's a plus 5, I do the opposite, which is a minus 5. But if I do it to the right, I have to do it to the left. 23 minus 5 is 18. And then that 3 is multiplying against the x. The opposite of multiplication is division. So I divide by 3, divide by 3. The 3's on the right-hand side will cancel. And 18 divided by 3 is 6. All right, number 12, we have solved the equation. We have 1/7 times t minus 8 equals a negative 8. I can't do anything inside of my parentheses. So what I'm going to have to do is I would have to get that 1/7 over to the other side. And there's a lot of different ways you could actually approach this problem. If you're 100% comfortable with fractions, you could distribute that 1/7 and then play with the fractions the whole time. But again, I'm going to always choose to not play with fractions if I don't have to. So remember on my steps from 2.4 and 2.5, it says if there's a fraction, the best thing to do is multiply by the least common denominator so you can get rid of that fraction. There's only one fraction in this whole equation, and it's the 1/7. The denominator for that is the 7. So I'm going to multiply everything, both my left side and my right side, by 7. If I do that, the 1/7 times 7 turns into a 1, which means I'm just left with a t minus 8 equals negative 8 times a positive 7 gives me a negative 56. And so what I can do there then is I can say, okay, well, I'm going to add the 8 to move it over. And I get t equals a negative 48. And that is my answer for this one. All right, number 13 says solve the equation. And then it says select the correct choice below, and if necessary, fill in the answer box. Because remember, on all of our equations, we actually have 3 options. Most of our problems are going to be x equals, where we find that our variable equals a specific number. But sometimes we will see what happens is that we get a true statement, like 2 equals 2, and there's no variables left, and that means we have all real numbers. Other times, what will happen is like we'll have 2 equals 4. Well, that's not true. And if that's not true, then what happens is we have no solution. And so these are all viable outcomes with our problems. And so we have to be aware of that when we go into these problems. So what we're going to do, we do our order, we go through our order. And the first thing I notice is that I have a set of parentheses over here, and I can't do anything inside of the parentheses. So I'm going to choose to distribute that 2 inside of the set of parentheses. That means I'm going to have 2 times x, which is 2x, 2 times 4, which is an 8. And then honestly, on the right-hand side, because we can kind of treat both sides of our equation separately, I'm going to go ahead and combine like terms over here. I'm going to save some space because honestly, I have very limited space on this paper. But I'm going to go ahead and take the 9x minus the 7x. 9 minus 7 is 2, so I have 2x. And then I have additional like terms, and that I have this 3, the plus 3 plus 5. Those are like terms, those are constants. 3 plus 5 is 8. Oh, look at what I have. Even before I move on, which I don't really even have to move on, what do we notice? We have a 2x plus 8 equals 2x plus 8. That's true because we have the same exact thing on both sides of our equation. If I subtract the 2 x's to move them over, you'll notice that they cancel out on both sides, leaving me with x equals x, or excuse me, x, 8 equals 8. This is a true statement. That means that the solution is all real numbers because we get the exact same thing on both sides, and it always works out nice and neat. So make sure you don't rush through your problems. That way, when you get to this step where you have 2x plus 8 equals 2x plus 8, you recognize that you have the exact same thing on both sides, and you're able to move forward with that. All right, number 14. If you don't get intimidated by the fact that it's like a whole bunch of fractions, you will do fine on this one. I promise. Because again, just like with that 1/7 problem, what I'm going to tell you is that if you have fractions in your equation, the best thing to do is to get rid of those fractions as soon as possible. And in this case, That means I'm going to need to find the least common denominator between 3, 6, and 9. And the way I like to find my least common denominators, which I'll do over here, and then I'll work the problem out down here. The way I like to do it is I take my largest denominator, which is 9, and I write out a couple multiples of it. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. You honestly don't have to go out very far. Usually 3 or 5 terms is about as far out as you go. And then here's the deal. 3 goes into all of these numbers. Why? Because 3 goes into 9. So I'm good. All of these would be fine. These would all be multiples of 3. I'm good to go. The question I need to ask myself is 6. Does 6 go into 9? And the answer is no. It does not go into 9 evenly. Does 6 go into 18? Yes. 6 times 3 is 18. So 18 is actually our least common denominator. So what does that mean for us? It means I need to multiply every single thing in this problem by 18. When I do that, what's going to happen is my fractions will completely go away. And I'm going to rewrite it down here so I have more space and you can see what I'm talking about. On the left-hand side, I have a minus 4 all over 3. And I'm going to take this fraction and multiply it by 18. This equals, and I'm going to go ahead and write the 18 first on this side. I have 18 times the 5a over 6 plus, and I will have 18 times the a minus 45 all over 9. So I rewrote the problem, but I put the 18s in there so that we can see what's going to happen. And again, as I did with like all the other problems, if I can simplify first, I'm going to. And I can guarantee you guys, you will always be able to simplify first on this because that's the whole point of finding the least common denominator. So 18, since I have a 3 on bottom, I want to make sure I have a 3 on top when I do the factoring here. 18 is 3 times 6. 3 times 6, so that means I'd have a 3 here and a 3 here, which means what I'm going to be left with is a 6 outside and then an a minus 4 because the bottom completely cancels out. This is the whole reason we do this, because we don't want those fractions anymore. Then I come over here and I say, okay, 18, and I have a 6 on bottom. Well, I just said 18 was 6 times 3. This time, though, the 6's cancel, which leaves me with a 3 times 5a plus. And then here, though, I have a 9 on bottom, so I need to think about how I make this 9 times something. Well, we actually just did that. It was 9 times 2. Gives me 18, so the 9's cancel, which leaves me with a 2 times a minus 45. And I don't know about you, I would much rather work with this equation than this equation, where I have to get common denominators and do the addition and then all that kind of stuff. I would much rather deal with this because this is all nice whole numbers, and I have a bunch of parentheses, and I can't do anything inside my parentheses. So I'm going to use my distributive property to get rid of my parentheses. 6 times a will give me 6a. 6 times a negative 4 gives me a negative 24. And here I can go ahead and do this as well because it's theoretically getting rid of the parentheses, but 3 times 5a will give me 15a. Plus I have 2 times a will give me 2a. 2 times a negative 45 will give me a negative 90. So now I'm going to look. There's nothing for me to do on the left side right now because these are not like terms. I have 6a minus 24 equals. But on the right side, I do have some like terms, and I have 15a plus 2a. That'll give me 17a minus 90. Now, I have variables on both sides of my equation. So what do? I got to get them together. So in order to get them together, I'm going to be moving either the 6a or the 17a. And what I always choose to do is to keep my variables positive if I can. So since I have more a's on the right-hand side, I'm going to leave those alone, and I'm going to move the 6a over to the other side by using subtraction because it's positive. So I use subtraction here. So I have a minus 24 equals 17a minus 6a will give me a negative 11, a minus 90. I need to get all my whole numbers to the left-hand side, so I'm going to add the 90 because it's in subtraction. So I add the 90 to the left-hand side. Negative 24 plus 90, or 90 minus 24, however you want to look at it, will give me a 66 equals a negative 11a. Oh, and it's not negative. If you were here, I hope you guys are yelling at the computer screen, because look at that, I had a positive 17a minus 6a. This is a positive 11, not a negative 11. See those pesky negatives? They'll come up and haunt you. They'll mess you up. So I have positive 11a, and in order to get that 11 over to the other side, I would divide by 11, divide by 11. The 11's on the right-hand side cancel. 66 divided by 11 is 6. Guys, I've been teaching this since 2012. This problem will always have a nice whole number answer, like 6. If you get some sort of a crazy answer, like 2/3, or a really wonky decimal, then you've done something wrong. Because you're always going to get a nice whole number like this shows, where we got 6. Yes, there's quite a bit of math to do in it, but that's okay. Take the time to find your least common denominator, multiply everything by it so that you get rid of your fractions, and then just solving an equation like you would back in 2.4, 2.5, which is actually where this problem originates, is in 2.5. So if you struggle with this problem in the practice final, do it and then regenerate it. Click that similar exercise button in the bottom right-hand corner. That way you can do it again with slightly different numbers, and you get the practice and you learn the steps necessary for that problem. All right, number 15, use the appropriate formula to determine the part A, area of a rectangle, and then part B, the perimeter of a rectangle. So here's the deal. You do need to know these formulas, and if you don't know them, then they need to make their way onto your cheat sheet. But we'll start with A. A is the area of a rectangle, which is going to be the length times the width. Length times the width. So that means the area is, we look at our picture that they provide, our length is 13 yards, times our width, which is 2 yards. 13 times 2 is 26. And here's the deal, guys. We have to also pick, if you look, we're going to have to also pick the units. So yards cubed, yards, or yards squared. Well, what did I just say? I said we took yards times yards. Yards times yards. What happens when you take something times itself and you want to write it? Does it just end up being yards? Does it end up being yards to the second power or yards to the third power? Well, how many did we have? We had 1, 2. That means we have to have an exponent of 2. So this will be 26 yards squared. Area always has a squared unit. Always. So we put 26 in the box and we select yards squared. Perimeter of a rectangle is going to be 2 times the length plus 2 times the width. So perimeter equals, because that's how much we'd have to go around the yard if we were to put in fencing, 2 times the length, which is 13, plus 2 times the width, which is 2. 2 times 13 is 26. 2 times 2 is 4. Perimeter equals 30. And when it comes to perimeter, you will always have just single units. So it's going to be yards. It's not yards squared, because yards squared goes with area, and the cubes actually come from volume, which we don't cover in this class. So area always has units squared. Perimeter always has just regular old units. So solve for x, and we have capital A equals x plus y all divided by 2. And here's the deal, we have to be really careful because some of our variables are capitalized and some of our variables are lowercase, and we have to type it in exactly like that or we will get it wrong. So on these problems, we have to isolate the variable they tell us to isolate. And in this case, it's the x, because it says solve for x. So I need to get x by itself. It has the plus y on top, but it's all being divided by 2. So my first step is going to be to move that 2 over to the other side. Since it's dividing on the right-hand side, to move it, I would have to multiply everything by 2. That will give me a 2a equals x plus y, because the 2 here would cancel with that 2. To get x completely by itself, I'd have to move this y. Since it's positive, I would have to subtract the y from both sides, meaning I'd have 2 capital A minus y equals x. So in my box, I would type 2a minus y. And again, I would do a capital A and I would do a lowercase y because that's the way they give it to me. And I don't want to miss this problem simply because of capitalization. So be extra careful on those problems. All right, number 17 says solve for m, and we have 21 over 9 equals 105 over m. If you have a fraction set equal to a fraction, you are allowed to do cross multiplication or butterfly multiplication. That's where you take the top of the left times the bottom of the right. So 21 times m is 21m, and you take the bottom of the left times the top of the right, which would be 9 times 105. So obviously I can't do anything with the 21m because they are already pretty much set, but I can take the 9 times 105, which will give me 945. In order to get m by itself, I would divide by 21, divide by 21, and I find that m is 45. So you have a fraction set equal to a fraction. This is the one and only time you can cross multiply. If there's any type of other symbol between these fractions, if I had a fraction plus a fraction or a fraction minus a fraction, I could not do this. It only works when I have a single fraction set equal to a single fraction. All right, 18 is our first word problem. It says, suppose that the exchange rate for the US dollar to the Mexican peso is $1 per 10.582 pesos. How many pesos would Elizabeth receive if she exchanged 300 US dollars? So this is from 2.7. This is where we set up ratios and proportions. And so we have to set up a ratio first, a ratio of American dollars to pesos. So I'm going to set 1 American dollar to 10.582 pesos. I apologize, I don't know what the symbol for a peso is, so I just label it with a lowercase p to indicate that it's a peso. And then in order to set up my proportion, that's where I set it equal, and then I set up the right-hand side, but I have to have American dollars on top and I have to have pesos on bottom. If I had flipped this and had pesos on top and dollars on bottom, that's totally fine as long as I have pesos to dollars. Like whatever's on top on the left has to be on top on the right. And our problem tells us that Elizabeth is exchanging 300 American dollars for X amount of pesos. And look at that, this problem is set up exactly like our last one in that we have a single fraction set equal to a single fraction, so we can cross multiply. We'll have 1 times x, which is x, and then we are taking 10.582 times 300, and that will tell us how many pesos Elizabeth is going to get. So you take 10.582 times 300, and it gives us 3,174.6. Notice it says type an integer or a decimal. I'm allowed to have a decimal here, and since they give me decimals in the problem, I can have a decimal here. Pay attention to these words on every problem that are in parentheses near your answer box because they tell you exactly the formatting that they want you to give your answers in. And if you don't pay attention to that, you could give the wrong format. 19 says express the given statement as an algebraic expression. Expressions are like equations, but there's no equal sign. It says 4 years less than 5 times the age, and they say A. A is the variable they want you to use for the age. So this one we have to be really careful because it says less than. If you see the word less than, or really specifically the word than, like more than or less than, what comes after that word is what you will write first in your algebraic expression. So for less than what? 5 times the age, which is A. 5 times the age would be 5 times A. Then for less than, that would be a minus 4. Subtraction is not commutative, so the order that you write it in matters. And if you have the word than in your statement, you're going to flip the order from the order that it's given on the page. So be careful. Okay. Next we have a word problem. And it says a salesperson is given the choice of 2 salary plans. Plan 1 is a weekly salary of $800 plus 3% commission in sales. Plan 2 is a straight commission of 5% in sales. How much in sales must she make in a week for both plans to result in the same salary? So we've got a lot of information here, and we're going to do a lot of converting because we have a lot to change from English into math. The first thing I'm going to note is that I have plan 1 is. That little word is, remember, is where we put our equal sign. So I'm going to write plan 1 is. Whoops, sorry. There you go. Plan 1 is. It says it's an $800 salary plus 3% commission. So I'm going to have $800 plus 3% commission. Now remember, when we deal with percentages, it's a percentage of something, and it's of her sales, which we don't know how much she makes or sells in a week. That's our unknown. And so we have to convert the percentage into a decimal, which is 0.03, and it's 3% of her sales. But we don't know what her sales are. That's our unknown. So that's what we're going to do. The second plan says plan 2 is a straight commission of 5% in sales. There's no salary for this one. It's just your sales. So it's 0.05 times X. That means if she doesn't sell anything that week, she doesn't make anything that week. With plan 1, she's going to make $800 a week regardless of how much she sells. So you have to take that into account whenever you're picking a job salary, if you're given that option, because you want to make sure that you're going to make the most money for what happens. Now the question asks us, how much in sales must she make in a week for both plans to result in the same salary? In math, when we think of things being the same, that means we're using equal signs. Plan 2 is the same as 5% of the commission. So if I want plan 1 and plan 2 to be the same, what I'm saying is I'm going to take plan 1 and I'm going to set it equal to plan 2. And if I do that, I'm actually going to be able to solve this. I just created an equation because plan 1 is 800 plus 0.03x and plan 2 is 0.05x. I have an equation now. I can solve this and I can figure out how much I'd have to make in a week for these two plans to make the same money. So I have x's on both sides, but I have more x's on the right-hand side. So I'm going to choose to subtract the 0.03x over, which gives me 800 equals 0.02x. In order to get my x completely by itself, I would divide by the 0.02. But if I divide on the right by 0.02, I have to divide on the left by 0.02. And if I divide 800 by 0.02, I find out that this salesperson would have to sell $40,000 in product or whatever it is they're doing in order for these two plans to be the same. Notice the number I got. I got 40,000. I didn't get 37,365.24823 or something crazy like that. I got a nice whole number. You will always get a nice whole number on this problem. And I'm saying that so that if you encounter something a little bit crazy, that will alert you to go back and retry that problem. Maybe you forgot that it was 3% of, and you left that part out. But you will always have a nice number for this problem. All right, 21. An isosceles triangle. Oh, we need to know what an isosceles triangle is. An isosceles triangle is a triangle where you have two sides that have the same length, and the corresponding angles in the bottom have the same measure. So in an isosceles triangle, one angle is 9 degrees greater than each of the other two equal angles. Find the measure of all three angles. Okay, so we have to know what an isosceles triangle is. We also have to know that all of the interior angles will add up to 180 degrees. And then from this, it also tells me one angle is greater than each of the other two equal angles. Well, this angle down here, we don't know what it is. I'm going to call it x. This angle down here, we don't know what it is. I'm going to call it x, because these are the same measure. That's what it means to be an isosceles triangle. So if I say this one's x, I got to say that one's x. And then it says one angle is 9 degrees greater than the equal angles. That means this top angle is going to be x plus 9. So now I have all three of my angles represented, so I can come over here and I can do the math to figure out what do these angles mean. Because all of the angles have to add together to equal 180 degrees to be a triangle. So bottom left, bottom right, top angle, x plus x plus x is 3x. Now I got to get x by itself, so I subtract the 9 from both sides. So I have 3x equals 180 minus 9 is 171. Divide by 3, divide by 3. The 3's on the left-hand side will cancel. And then I take 171 divided by 3, and that tells me that x equals 57. Okay, so if x is 57, that means this angle down here is 57. That means this angle down here is 57. But this angle up here is going to be 57 plus 9, which is 66. These are the numbers I need to know. Because my answer boxes are right here, and it says the smaller two angles are each, well, they're each going to measure 57, and they give you the little degree symbol. You don't have to worry about that. The larger angle is that 66 degrees. So you have to know isosceles triangle has two of the bottom angles equal, but you also have to know that when you add up all of your angles to your triangle, it's going to equal 180 degrees. All right, let's do our money problem. We got Alexandra is investing, or has invested, $10,684. Part of it at 9% simple interest and part of it at 3% simple interest over 1 year. So how much did she invest at each rate if the accounts earned the same interest? Guys, we're pretty much going to be doing the exact same thing we did above with our sales plans. We really are. The first thing, though, that we need to remember is that when doing our interest equals principal times rate times time. And back in chapter 3, we did this with a table. And if you like the table, use the table. Since we've done systems of linear equations, we don't really have to do the table anymore because we can just set up our equations if we want to. It's really up to you. I'm going to choose not to use a table because you've seen me do the tables a lot of times, and so I'm not going to choose to do the table, but I am going to make like a little diagram to help us understand what's happening with all this information that we are given. So we know that Alexandra had invested $10,684, and she split this up between two different accounts. One account paid 9% and one account paid 3%. Now, we don't know how much she invests at either one of those. So I'm going to say she put X amount of dollars at the 9%. She put Y amount of dollars at the 3%. But here's the nice thing. Both of these was for a period of 1 year. So when it comes to our equation, the T time, like the time just becomes 1. So it's really obsolete. We don't even have to worry about the T. So really we're thinking about interest as principal times rate for this problem. And we have our principals here times our rates. And here's the thing, we want these things to be the same after that 1 year. And when things are the same, we set them equal to each other. So that means I'm going to have the interest at 9%, and that needs to equal the interest at 3%. Well, the interest at 9% is going to be 9%, which is 0.09, times x. And if you really want to include the 1 in there because it's going to bother you, then also put times 1. The interest at the 3% is going to be 0.03 times the principal, which is the y. Now the problem is I can't solve this because I don't have enough information because I have two variables in the same equation. But something else I know comes from the fact that I put X amount of dollars here and Y amount of dollars here, and I know that the grand total was $10,684. So what I know then is I know that if I take X plus Y, the amount invested here, plus the amount invested here, I have to get $10,684. It has to add up to this total. Well, guys, what I just did is I have an equation here with x's and y's. I have an equation here with x's and y's. I just made a system of equations. I can solve a system of equations. We learned how to do it graphically. We learned how to do it with substitution, and we learned how to do it with the addition method. What I highly recommend doing is I recommend doing it using the substitution method, because over here, if I just subtract the y over to the other side, I have x equals $10,684 minus y. I have my x, excuse me, completely by itself. And if I have x is $10,684 minus y, I can substitute that into my other equation in place of my x, and I can solve for my y. So that's exactly what I'm going to do. Instead of 0.09 times x, well, x is the same thing as $10,684 minus y, and that equals 0.03 y on the right-hand side. So I need to take 0.09 times that 0.09 times 10,648, and that's going to give me the 961.56 minus, and then I distribute that 0.09 to the y equals 0.03 y. Sorry, I'm working my calculator. I don't need my calculator for right here, but I'm going to need it in a minute because I need to get my y's together, so I'm going to have to add 0.09y plus 0.09y over here. So I have 961.56 equals 0.03 plus 0.09 is 0.12y. Just barely running off the screen for you. Divide by 0.12, divide by 0.12. So I have to take the 961.56 divided by 0.12, and I find that 8013 equals y. So one of the reasons why I highly recommend either using a table or using some sort of a diagram is because at this point I found that y is 8013, but guys, I have no idea what y was. But luckily I have this little diagram over here, and it says y is the amount that I invest at 3%. Awesome, because look at my question. It says Alexandra invested so much money at 9% and so much money at 3%. So I just found that she invested $8,013 at 3%. And so how do I figure out how much she invested at the 9%? Well, I know that x plus y equals the $10,684. So I can take this 8,013 and I can plug it in to figure out what my x is. Because x equals 10,684 minus my y. Well, my y is 8,013. So I'm going to take that $10,684 minus the 8,013, and I find that x equals 2671. And again, with my diagram, I don't have to remember what x was. X is the amount invested at 9%. So in my answer box, it's going to be 2671. You can use the tables from the problems that we did back in chapter 3. If you really like the tables we did in 3.4, you can totally use the table in this problem. But now that we have systems of equations from chapter 9, we actually don't have to use a table. We can just write our equations and do the substitution method in order to solve for this. And even though the numbers are a little bit weird, you know, they're still whole numbers, I guess is what I'm trying to point out to you. We didn't get a weird, crazy decimal. We got a nice whole number situation happening here. And so be aware of that again, so that hopefully you can spot little errors if you're starting to get some really crazy answers and like that. All right, let me take this sheet and move it. Ooh. All right, I'll do my best with this one, simply because I know I can't really enlarge it much for you. But number 23 is where we're given a Cartesian coordinate system, and it's already got a bunch of points labeled, and we have to then type the coordinates as ordered pairs. Remember, with an ordered pair, if you do not have parentheses around your numbers, it is not an ordered pair. So you have to have that. If you just put 2, 1, then it doesn't work. You will get it counted wrong every time. Okay, so over here, A is right here. And remember, your x coordinates come first, so that's your horizontal movement. So if I'm looking horizontally, that's at -6. So I'm going to go comma, or parenthesis, -6, comma, and then my vertical change is down here. It's at -3. And again, you have to have parentheses around these numbers. Then I go look at B. B has horizontal movement over to -3. But if you look at it, it's right there on the x-axis. It has no vertical movement, so I cannot go up at all.